Welcome to Tech Notice. In this video, I'd like to show you how you can actually test your PC and make sure that after you've built it, the performance is good, your actual cooling is good enough or adequate enough, how to measure it, which benchmark should you run, and how do you know if your PC is doing good enough of a job. So let's go.
Looking for a cheap way to license your Windows? Check out WhoKeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out whokeys.com in the video description below.
So before you even start configuring and updating Windows or doing any of the drivers and stuff, first thing I think you should do when getting a PC to make sure that everything is running properly is the latest thing is update the BIOS. BIOS is basically just operating system or system that's inside the motherboard that makes sure that all the components work together. So it's just the operating system that talks to the CPU, RAM, looks at all your storage and PCIe slots and all the fan curves and everything, and make sure that everything works together. And it also recognizes what CPU there is, what RAM there is, what RAM speeds should we be running, and what voltage should be pushed to the CPU and so on. By updating your BIOS, you can actually reduce the wattage of a CPU or actually increase the performance of a CPU as well. Many times now, especially with the 12th gen or new platform release, you get a motherboard, it's got very early versions of the BIOS, the CPU will run and it's going to be performing, but later on they can reduce the voltages and they can reduce the wattage of the CPU but still get the same performance. First thing you do, update the BIOS. If you don't know how to do that, there's plenty of tutorials out there. Let me know if you want me to make you one, comment below. Secondly, what you want to do is you go to your Windows updates. Check for updates. You go to this page and then you're going to check for updates, and you're going to click on that check updates and install and restart. It's going to do lots of boots and so on, and you're going to do that until it says you're up to date, and then that's it. Okay, you know that there's no more updates for Windows. That's step number 2. Step number 3 is update all the drivers. No matter which motherboard you come with, it actually has some kind of software that will know what components have been installed, and it's going to update and install the drivers for like all your Bluetooth, Wi-Fi, networking and so on. So at the moment we're using Gigabyte Z690 Aero D motherboard, the Create the motherboard. Very good motherboard, highly recommend this. And if you've got the Gigabyte motherboard, what you want to install is something called Launch App Center Program or App Center Program. Usually when you install Windows, it straight away asks you, do you want us to download this? And you should say yes, and then it's going to update this. Now once you're there, you can see this bit over here. If you're on ASUS board, it's Armory Create that you want to install, and you can do exactly the same thing there. There's a section where you can find like updates. Basically, you go to live update, and here now it's going to search for updates for all the components inside and make sure everything is up to date. But don't install lots of random software for it, because it's already it will give you an option to do that as well. So do not do that. As you can see, there's lots of utilities that you can install. We don't want any of them, and then we don't want 30 like Norton Internet Security. We don't want that as well. But if you do have any updates of like your system, then it will give you another like selection there of driver updates, and then I have done them all, so that's why it's there. As you can see, I've selected the top part over there. Necessary system driver update, Microsoft Windows update, requires internet connection. We're just going to install that as well. Once all of those are updated, then you need graphics card drivers as well, which is very important. If you have Intel's 12th gen system, or actually any Intel system, and that has an iGPU, if your CPU is a non-F variant, so if it doesn't have an F in the name, it will have an iGPU, and you want to install the graphics drivers for your actual CPU, because it's got a graphics card inside there, iGPU, and then you want the graphics drivers for your GPU or dedicated graphics card as well. In fact, this discrete graphics card. So at the moment, I'm actually installing the graphics card here for my NVIDIA. We're gonna go custom, perform clean install. Whenever installing graphics card drivers, always perform a clean install on the drivers. You don't want any of the older drivers. As you can see, our current version is very old, new version is much newer. And then how you install the Intel graphics card drivers there is something called Intel Support Assistant. driver and support assistant. There we go. Download this, install this program. What this basically will do is just checks that all the Intel components inside your PC will have the latest drivers, whether it's Bluetooth, Wi-Fi, networking, or even the graphics card drivers inside the CPU. As you can see straight away, it already knows that there's 2 updates available, which we're going to do that. Restart is required. We're going to do the restart when NVIDIA drivers are installed as well. And you might be saying, I thought you're going to talk about how to actually test your CPU's performance and make sure your CPU, or PC runs like it should be, and actually stress test your PC. And yes, and the thing is, if any of those steps that I've just told you, BIOS, Windows and drivers aren't up to date, it might not, sometimes it can, but it might not run with the latest kind of performance, or it might actually be unstable because some of the earlier stuff is unstable. Basically, you need the latest version of the drivers or everything, before you do the stress test to make sure that everything's working. Okay, NVIDIA drivers installed. We'll restart the system to get the Intel driver installed as well. Look, once the Intel driver support assistant is here, you can see it straight away on the bottom corner there. We're gonna check for new drivers. As you can see, the Intel graphics driver is ready here. We're going to download that. That's a very important driver to get all the iGPU working properly. Once all of these 3 things are updated, BIOS, Windows and drivers, we can start to stress test the system and see how well they work. Now, one of the first things we want to test is the CPU. Like, we want to make sure that our CPU gets good thermals, it performs nicely. So I highly recommend you go to Microsoft Store and then search for an app called Cinebench. You can download it for free, and basically what this test is the CPU rendering performance. Some people think this is not a very helpful test, but actually it is a very helpful test for creators because this is basically benchmark for Cinema 4D. And if you're using Cinema 4D for anything, then this is very important for you. I have already downloaded it, so I can just open it, and there we go. Now, in order to measure what's going on with our CPU, we need something that looks at the hardware and looks at the sensors inside there to actually measure what's going on. For that, I highly recommend downloading something called Hardware Info 64. It says download Hardware Info 64. This is great. And then you have here this installer. On the left side, you're gonna go to free download, and I'd recommend going local, and then this will get you the latest hardware monitor. You just click on it. You can install it here by just next, accept, next, next, next. But I have already downloaded it and installed it, so I don't need to do this. I'm gonna exit setup. If you have installed it, you just go Windows, Hardware Info 64. We're gonna hit yes, we wanna make changes. And then just tick this box over there, sensors only, because then we don't have all the other stuff that this program can do as well. So you can just press that and we can measure and see what's going on in our CPU. Now you have lots of these things going on around here. Make sure that you have something open here called like the core clock speeds. So CPU Intel Core i9-12900K, that's what we have installed in the system there at the moment. And then another thing we want to see is this section over here where we can see CPU package temperature. So this section on the very left side here shows you what it's actually running at the moment. So our temperature currently is 41 degrees, 39 degrees, running like that. Next column, we have the minimum, and then we have maximum and average as well. So you don't really need to look at those, but just the current power draw there. But the maximum will be very helpful as well to see. So now, once you have Cinebench open, you might want to go to Advanced, File and Advanced, because then you'll see something like this over here. It gives you a few options. How long do you want to do this test, basically? Firstly, I'd recommend you do single test. So this is off, you press start, pick up the hardware monitor so you can see what's going on. So you can see our clock speeds here are 4.9 gigahertz on the P cores, so they're the performance cores. And then the efficiency cores are running at 3.7. And then here we can see that our CPU package is running at 212 watts. And our CPU package temperature is 79 C, something like that, running at 80 degrees, which is actually pretty good for the 12900K. And now we've got a score here, 27,023. Now, if you're wondering, like, how do you know if this is a good score or bad score? Should I be getting higher score or lower score? A good thing to do is just go check out my benchmarks on TechNotice YouTube channel. Just type in TechNotice, type the CPU, the 12th gen, most likely I have done benchmarks for that. And then you can see the scores that I have got. If you get something, you know, within the same ballpark, it's all right. But if you want to get another option, what you can do is go to a website called CPU Monkey. cpumonkey.com, and now we can go to benchmarks, Cinebench R23 multi-core benchmark. And then here now scroll down until you see your CPU. Now, as we can see, the 12900K is getting 27,472 points. And we are getting about 400 points less, but I bet you if we did it again, we can get it a lot closer than this over here. And that's completely fine. If you get a score within 1 or 2% of what you're getting on CPU Monkey, it's completely fine, because sometimes it scores a little bit higher, sometimes a little bit lower. It's all right. If it's 1 or 2%, it's no problem. If you get more than 5% difference, what you can see online, then there's something going on, or something's wrong and something's not quite running properly. See, this time 27,346. That's a much better score. It's what it says online, and there we go. And you can do the same on the single core. The single core will take a longer time, but when you're doing these benchmarks, don't do anything else on the computer, because that will affect the performance. And if you're getting lower scores, you're gonna be like, what's going on? It's just because you used other things and the CPU kind of resources were used somewhere else, and it couldn't just put everything on the test or benchmark. So don't do anything else when you're doing that. Another thing you might want to do is a 10-minute test, basically over here, and that will show you how good is your cooling in the long run in 10 minutes. But also I would recommend doing a 30-minute one if you have time for that, where you basically can now see what's the difference between the score of a single core test, as you can see 27,000 over here, and then do a 30-minute test. That will show you how good the cooling is. If your test results are within like 2, 3, 4% of the original, just a single core test, then your cooling is completely fine. If you're getting more than 4% difference, then that just shows that your cooling isn't, cracking it in the long run. Now, you might be okay with this, but if you have like 10% or 15% difference, that really shows you that your cooling is not adequate for this system, especially if you're a creator who does like longer run. It might be in the short term, but in the long run, it's not going to be adequate for this at all. Now, when we're looking at our test over here, we can see that our clock speeds are very good in terms of P cores. We can see the maximum we've hit is 5.2 gigahertz, which is advertised by the manufacturer. The E cores have hit all 3.9 gigahertz. We're way below the actual temperatures. So by the way, if you're hitting 90 plus degrees in the maybe 10-minute run or something like that, then you might be start to look at, okay, maybe we need to adjust our fan curves or pump curves, or depending what cooling you have. It's a little bit hot over there and you don't want to constantly live in the 90s. But if you're hitting 83 or below 90, like between 80 and 90 in the actual synthetic benchmarks like this Cinebench R23, then it's completely fine. Don't worry about it. If you're idling somewhere around 42, depending on the ambient temperature for you as well. At the moment, I'm idling about 40 degrees, and that's completely fine. If you're idling above 50 or in the 60s, something's wrong over there. You might want to check your thermal paste application, or making sure that your cooler is properly, installed on your CPU socket there. At the moment, I am happy with my CPU, performance. I think the CPU is going good. Everything is going fine. And next off, what we want to do is RAM. Now, if you are a creator and using Adobe programs, then I highly recommend you download something called Puget Benchmark for Photoshop. If you have Photoshop and you're using Creative Cloud, and do the Photoshop benchmark. It's very easy. You go to your Creative Cloud, go to plugins and search for Puget Bench for Photoshop plugin, and then you can download it. It's super simple. And then go to Photoshop, you go to Window, and then you go extensions over there, and then you can click start in the actual Puget benchmark for Photoshop, and then run that benchmark with your XMP enabled. And that is very good test I have found for RAM stability, because the Photoshop will use a lot of the RAM and the RAM speed and everything, so it tests like kind of the stability of RAM as well. If you're getting a blue screen of death, or you're getting some kind of a crash during that test, the XMP for your system might not work so well. Because at the moment I have 2 sticks installed over there, even though there are 4 there, 2 of them are fake, 2 of them are actually real, and they're running at 6,000 megahertz. And now if I did the test, I've actually done it, it's completely fine there, and they run at 6,000 megahertz. If it crashes during the Puget Bench test on Photoshop, then what you have to do probably in order to get the stability for your system is go to BIOS and then take the XMP off, or try the lower XMP, because I think there's 2 XMPs available, like a higher 6,000 and this other one might be 5200. Try if the 5200 works, depending on your RAM configuration. There's few available on BIOS. Or just take the XMP off, and then you'll see that it will run stable. If you don't have the Creative Cloud and you still want to test your RAM stability and how to get, make sure that your RAM works perfectly, you can do a lot of synthetic tests and then like ADA and RAM tests and so on. But what I'd recommend for like more simpler way of doing it is run as many different benchmarks as you know. Just run them, whatever you can find, run them. Some of them use RAM and they use them differently and they all use differently. Just run as many benchmarks as you can. And if you don't have a blue screen of death or a crash, most likely your RAM is going to be fine. Because if the system can't run the XMP on the RAM system and that actual megahertz, it's most likely going to crash in most of them. I have found that if it crashes on Photoshop, it also crashes in DaVinci Resolve, it also crashes in Premiere Pro, it also crashes in a lot of different places. Now, Cinebench and Geekbench 5 aren't very good at that because often I can still pass the Geekbench and Cinebench tests without crashing this. Crashing on the RAM and the XMP can work, but then when running something more RAM intensive, then it crashes. And next of all, moving on to the GPU stress test. And what we can do over here is you can download a program called Firmark. There we go. Go to this page over here. You have Firmark and then you just click download. Firmark latest version, as you can see, is 1.3.00. You can go here. It's going to go download and you can see, boom. Just install that to your system. And then once it's installed, you'll just go Firmark. Open the program. I have a little bit of an older version actually. So yeah, 1.26. As you can see, there's newer versions available, but it still works completely fine. Now, what I'd recommend you to do is go to resolution, and then depending on your GPU, go either 1080p or 4K. I'm gonna go 1080p at the moment, and we're gonna go to GPU stress test. It's gonna give you a little bit of a warning, press go. And then now what this is gonna start to do is just stress test your GPU. And this graph on the bottom over there just shows you GPU temperature. It will show you minimum and maximum and current GPU test over there, or temperature there as well. And I highly recommend you do that test with the actual side panel closed if you have the side panel, because then it will really show you if this is adequate cooling and if this is adequate airflow to your GPU. Once this is running, I'd still recommend you open the hardware info, and if you scroll all the way down, you can actually see your GPU stuff as well. As you can see, the GPU, I have an RTX 3080 installed over there, and we can measure the temperatures and what's going on in there. We can see that the memory junction, we can see the memory temperature is 86 degrees maximum, and then the GPU temperature is around 67 degrees there. Let it run about 15 or 20 minutes until you see this graph over there pretty much plateau. So it's not going higher, but it's just hovering around the same kind of temperature. That will show you where's the GPU going to be maxing out and what the temperature it's going to stay at, like when it actually normalizes and stabilizes its temperature, where it's going to stay at. Sometimes it takes 10-15 minutes, sometimes it takes only a few minutes, and then that's that. It depends on your GPU, depends on your ambient temperature, it depends on your cooling, it depends all sorts of things. Just let it run until it's actually plateaued, which we're going to do now. Okay. As you can see in our system over here, we have ran it now for about 4 minutes, and can you see how the graph has plateaued? It's not going any higher. It did climb over there, and then now it's pretty much the same. Now this is going to show you just how good the GPU cooling is. And also another thing that's very important is the GPU power. Now you want to make sure that you're getting the actual exact power that you need from the GPU. We are pulling 370 watts from the actual GPU. This GPU is actually overclocked. This is not a normal, the reference model will be 320 watts, I think, or something like that for the TGB. But we're getting the good temperatures. Is it able to cool it down? Yes. The memory is 88C. That's completely fine over there because the memory maximum is about 110 degrees. If it's that, you really want to, if it's over 100, the memory, you're probably going to be running something hot, then, maybe worth either changing GPUs, or maybe there's something wrong or something like that. That's that. Our hotspot of the GPU is about 81C, which is quite all right considering this is about 30 degrees here in this room at the moment. It's very, very hot. And the GPU temperature is actually 69 degrees, about 70 degrees, which is very, very good. So the cooling of the GPU is very adequate. It is able to keep up with it even though the hotspot is higher, it's completely fine. Another thing, you might want to watch the GPU clock speeds and what the clock speeds will be. If the clock speeds are going to go massively down and keep going down and down and down, and it can't hold them around there, then that might be a problem. Obviously, my boost clocks here are about 1.9. That's where it boosted, but at the moment it's running about 1500 there. You might be looking at that as well. This Firmac test is very, very synthetic, and if you're a creator and using the actual GPU, then you most likely are not going to see that intensive GPU workflow. The same with the Cinebench. They're very, very hard on the CPU, and any other program out there, unless you're using Cinema 4D, even in like real world Cinema 4D rendering, you might not even see that much of the CPU used. But if it passes on both of these, Firmac and Cinebench R23, then you know that your CPU and GPU can handle any other software or application, whatever you're using, because it passed those synthetic benchmark, because your application will not be that intensive and is not going to be using that CPU like that. It's going to be using it in peaks of performance or somewhere 70%, but it will never run it like that because no application can actually utilize this. That's why it's good to run those benchmarks, because they're all the same across platforms everywhere. You can do it, any devices basically, but it will test the worst case scenario. If it passes those, your system is fine. So my friends, you might be very advanced and you might have already known this, but I think a lot of people are getting more into PC building, especially if you're a creator and you want to, build yourself video editing, photo editing, graphic design, music, 3D PC, and you're wondering, is my PC doing all right? Or you might have got a PC from someone and you want to test these. You can test it even if all PCs, laptops, anything. I would do exactly the same test. You can download and install these programs in whatever PCs, even on Macs. Unfortunately, if you have a Mac, you can't really get this hardware info. It's not so easy to actually monitor the hardware inside your Mac. So yeah, it's really for PC build. So my friends, let me know what you think in the comment section below. If you want to check out this PC build or a creative PC build for different budgets, the best bang for buck budgets, then you can find them in the description below. $1,000, $1,500, $2,000, and $2,500, and finally $5,000 PC build for your creative needs. They're linked below. Thanks guys for watching. Likes and subs, and I'll see you soon. Bye bye.